Hi everyone, my name is Nikhat and I'm going to explain the project MiniShell. The operating system acts as an interface between the user and the hardware. For the user, the interface can be either in form of graphical user interface, that is GUI, or command line interface, that is CLI. Windows operating system is an example for graphical user interface. Before the graphical user interface was supported by operating system, it was mainly operated by command line interface. It was given different names in different operating systems. Some popular examples can be DOS prompt of Windows or bash prompt of Linux. These interfaces typically run in a text window, allowing the user to type commands which cause actions. Upon receiving the commands, the operating system will parse the commands for its correctness and invoke appropriate application to perform a specific action. This action can range from opening a file to terminating an application. In case of Linux, the bash shell reads commands from a file called a script. Like all other Unix shells, it supports piping and variables as well, and eventually provides an output. The goal of this project is to implement a MiniShell that mimics the bash shell by using Linux kernel system calls and IPC mechanisms, that is interprocess communication mechanisms like signals. It will handle a set of commands and also handle special keyword actions, for example Control C and Control Z. This project can also be extended for advanced functionalities like we can implement command history as well. By implementing this project, we can get real-time perspective about using Linux system calls to develop an utility like command line interface. So next we will see the requirement specification. So these are the specifications that needs to be implemented, that is the prompt, external commands, built-in commands, special variables. So we are going to implement using the system calls, process and IPC and signals. So we are going to implement this all things, that is prompt, external commands, built-in commands, special variables, using system calls, process, interprocess communication and signals. Now we will see about prompt. Provide a prompt for the user to enter the commands. So we have to provide a prompt so that the user can enter the commands and execute the commands. Display the default prompt as MiniShell followed by a dollar symbol. So we have to display the default prompt as MiniShell followed by a dollar symbol. Prompt should be customizable using environmental variable ps1. So if the user wants to customize the prompt, the user can customize the prompt using the environmental variable ps1. To change the prompt, user will do ps1 equal to new prompt. So here we can see we have not given any spaces here. So if the user wants to change the prompt, then he has to write the prompt in such a way that there are no spaces in between the words. So you have to make sure that you do not allow white spaces in between. That is, do not allow ps1 space equal to space new prompt. So you have to not enter the prompt in this way. So if you are entering the prompt in this way, then it will be treated like a normal command. So you should make sure that you are not giving spaces in between. So if you are giving spaces in between, it will be treated like a normal command. If you do not give spaces in between, then it will be treated like a prompt. So if you want to change the prompt, use the environmental variable ps1 and give the prompt name without giving spaces in between. So this is how you are going to customize the prompt using the environmental variable ps1. Prompt should be customizable using the environmental variable ps1. ps1 equal to user at msg. So here I have given the prompt in such a way that there are no spaces in between the words. So if we are giving spaces in between the words, it will be treated like a normal command. So you have to give the prompt name without giving spaces in between, like in this manner which I have shown over here. See, as we can see, there are no spaces in between. So we have to give the prompt in this way. So if we are giving the prompt in like this, like if we are giving spaces in between, then it will be treated like a normal command. Prompt should be customizable using the environmental variable ps1. So see, this is the correct way. to customize the prompt, and this is wrong. If we're trying to customize the prompt in this way, then this will be treated like a normal command. So if you want to customize the environmental variable, use this method, that is without giving spaces in between. So this is a correct way to customize the prompt. The next you will see how to execute the command. User will enter a command to execute. So whichever command the user wants to execute, he will enter the command. If it is an external command, create a child process and execute the command. So we have to check whether the command is internal command or external command. If it is external command, then create a child process and then execute the command. So after creating the child process, then we can execute the command. Parent should wait for the child to complete. So the parent should wait here until the child completes his execution. If the parent terminates first, then the child will become orphan. If the child becomes orphan, then the child process will be adopted by a special process, that is init or systemd. In some systems we call it as init, and in some systems we call it as init. So once the child become orphan, then the child will be adopted by the init or systemd. So we should make sure that parent do not terminate first before the child terminates. If parent is terminating, then the child will become orphan, which we do not want in a case. So for that purpose, we should make sure that the parent waits until the child completes its execution. So once after child completes its execution, the parent can terminate. Only on completion, MiniShell prompt should be displayed. So after the child completes its execution and once the parent terminates, then we can display the MiniShell prompt back. If the user press enter without a command, then it should show the prompt again. So if the user is pressing enter from the keyboard, then it should show the prompt again. So this is how we execute the command. In this project, we have to implement some of the built-in commands. So we will see which are the commands which are to be implemented. So first is the exit command. Exit command will terminate the MiniShell program. So we have to implement the exit command. This command will terminate the MiniShell program. The next command is the cd, which stands for change directory. So we have to implement the command cd, that is the change directory. This is used to change the directory. For example, if you are in the root directory and if you want to come to the users directory, then you can use the command cd, or if you want to go to the parent directory, you can use the command cd and change the directory whichever you want. So cd command is used to change the directory. It is a built-in command. Then next is pwd. Pwd stands for print working directory. So this command is used to show the current working directory. So in which directory you are working in. So if you want to know in which directory you are working, then you can use the command pwd. So pwd is a built-in command which is used to show current working directory. So we have to implement all these commands, that is exit command, cd command, pwd command. Next we will see special variables. Exit status of the last command echo $?. So this we will see what this echo $? Will do. After executing a command, the exit status should be available. So once a command is executed, the exit status of the command should be available. Echo $? Should print the exit status of the last command executed. So whenever we give the command echo $? This should print the last command executed. So whichever command we have executed previously, the exit status of that command should be printed whenever we give echo $? PID of MiniShell echo $. PID stands for process identification number. Echo $? should print MSH PID. MSH nothing but MiniShell's PID. So echo $? should print the PID of MSH, that is MiniShell. The next is shell name, echo $shell name. Echo $shell name should print MiniShell executable path. So here we are implementing some of the special variables wherein echo $? should print the exit status of the last command executed, and next special variable is echo $. So this should print the MSH PID. Then next special variable is echo $shell. This should print MiniShell's executable path. So this was about special variables. Next we will see about signal handling. In Linux, signal handling is an essential concept for managing and responding to asynchronous events or interrupts that occur during program execution. Signals are notifications which are sent by the kernel or processes to a running program to indicate events like errors, user interruptions, or specific conditions. Linux supports various types of signals. Each signal is identified by a unique integer value. Some of the common signals are SIGINT, that is whenever we are going to press Ctrl plus C, a SIGINT signal is sent to the process. SIGSEGV, whenever a segmentation fault occurs, so SIGSEGV signal is sent to the process. So if you want to terminate the process, that is if you want to forcefully terminate the process, then we have to use SIGKILL signal. Then if you want to send termination request for the process, then we have to use SIGTERM signal. So in short, signal handling is nothing but we are providing shortcuts to send signals to a running program. So using signals we can convey to the process to stop processing or to stop executing. So here in this project we are going to implement Ctrl plus Z and Ctrl C, that is we are going to send STP signal to the process and SIGINT signal to the process. So here whenever we are going to press Ctrl plus Z, at that time we are going to send STP signal to the process, that is we are going to tell the process to stop executing. On pressing Ctrl plus Z, the program which is running in the foreground should stop and the parent will display the PID of the child. So once we signal, that is the STP signal is received by the process should stop and the parent should display the PID of the child, that is PID of the process which has been stopped. PID is nothing but the process ID. So once the signal is received by the process, that is STP signal is received by the process should stop. So this is about Ctrl plus Z signal. The next is Ctrl C. So whenever we are going to press Ctrl C, we are going to send SIGINT signal to the process. On pressing Ctrl C, if a program is running in the foreground, send SIGINT to the program, that is to the child process. So if the process is running in the foreground and if your process and if you are pressing Ctrl C, at that time we are going to send a SIGINT signal to the process, that is to the child process. If no foreground process exists, redisplay the MiniShell prompt. So if there is no process running in the foreground, we are going to redisplay the MiniShell prompt. So this was about Ctrl Z and Ctrl C. So whenever we are going to press Ctrl plus Z and Ctrl C, we are going to send SIGINT and STP signal to the processes. So on receiving these signals, the process will stop executing and the PID of the process will be printed by the parent process. So this was about signal handling. So these are the commands which we need to implement. We need to implement here system calls, cd, that is change directory, mkdir, that is the make directory, rmdir is used to remove the directory, sleep, exit, pwd is print working directory, interprocess communication, npipes, process, ls which is used to display the contents of a directory, date command which is used to print the current date and time, any executable file, echo family, echo $, echo $, echo $shell, ps1, that this is the environmental variable using which we are going to customize the prompt. We are going to implement here signals, SIGINT and STP. So we are going to send the SIGINT and STP signal to the processes. Then next we are going to implement FG, that is FG will bring a background process to a foreground. FG will bring only the last background process. Then next is BG. BG will move a stopped process to the background. Then next is jobs. Jobs will print all the background process details. So these are the commands which are to be implemented in a project. Now I am going to show the demo of the project. So these are the files which are needed for the project. I have created all the .c and .h files which are needed for this project and I have stored in this folder, that is MiniShell. So let me compile all the files and show the demo. So I am going to use the command gcc star.c to compile all the files. So as we can see here, there are no errors and no warnings. So I'm going to get the executable file, that is a.out file. I'm going to run the a.out file. So this is the mini shell which I have created. So this shell will behave exactly like the bash shell. It can perform all the functions which the bash shell can perform. So I will execute some commands and I will show. So first let me execute ls. ls will list the contents of the current working directory, like it will print what all contents are present in my directory. So see here, all the contents have been displayed over here. All the files which are present in the MiniShell project, all the files have been displayed over here. Then next we will see echo $$. This echo $$ should print the PID of the MiniShell. So this is the PID of the MiniShell. Then next we will see echo $?. Echo $? Should print the exit status of the last command executed. So see here, it is printing the exit status of the last command which is executed. The next is echo $shell. Echo $shell should print the MiniShell's executable path. So this is the executable path of the MiniShell. So it is printing the executable path. Then next we will see date command. So if I type date, it will print me the current date and time. So see here, it is printing me the current date, that is June 4, and the current time. So then next we will see PS. So the PS command in Linux is a powerful tool that allows you to view information about the processes running on your Linux system. It stands for process status, and it's a command that you can use from the command line to get information about the processes which are currently running. So we will see which are the processes which are running in a system. So see here. So these are the processes which are running in a system. One is the bash, one is the a.out file, and one is the ps command. So there are three processes running in a system. Then next is, so I have stored one file.txt file. So let me show you the contents of file.txt file using the cat command. So see here, it is displaying me the contents of file.txt. So this is the cat command has been implemented successfully. So if you want to print any message on the screen such as hello world, you can print using the command hello. So see, hello world has been printed. Then next is, if you want to implement Control Z signal, that is if you want to stop the process. So see here, stop, Control Z has been implemented. So if you want to implement FG, no process in background to run in FG. If you want to implement BG, kill, no such processes. Then next is ls-l, that is long listing the contents. So see here, all the contents have been long listed. So RWX stands for read write executable. So these are the permissions of the file. So this is the date and time, this is the name of the file. So it has read write executable permissions. So some has read and write, some has read write executable, all three permissions. Then next is, if you want to implement piping, ls-l pipe wc-l. See, command at 0, command at 3 created pipe. So here we can see the pipe functionality has been implemented successfully. That is, we are printing the world count, ls-l piping wc-l. So see here, the pipe functionality has been implemented successfully. Next we will see how to change the directory. Now let me show you in which directory I am in. So this is my current working directory, that is MiniShell. If I want to come back to this desktop, so I have to do cd dot dot, so it will go back to desktop. So let me print the directory. So see here I am at the desktop. If I want to come to the root directory, I can give as cd dot dot slash dot dot pwd. So see here I am in the root directory. So this is how we implemented the command cd, that is to change the directory. So if you want to clear all the above things, then you can use the command clear. All the things will be cleared. So let me execute and show. So see here all the things have been cleared. So this is how I have implemented MiniShell, which is similar to a bash. Like it can perform all the functions which a bash shell can perform. It can execute all the commands which a bash shell can execute. So this was about the project MiniShell. Thank you.